2 minutes for this. When 2 minutes is lot. Highest magnetic moment. Yes, Maria, correct. Very good. By the way, Maria, how are you?
I'm fine, sir.
You were not present in last few classes.
So I had to prepare for a computer science exam, so I had to revise everything up. That's the reason why I couldn't join.
When is your examination? JEE?
I got it on 5th, first shift.
5th. I have got another answer. Fadil, yes, Fadil, correct. Few more seconds. The time is up. Magnetic moment, it only depends on what number of unpaired electrons. So in these, and we have 1, 2, 3, 4, 5, 6, 7. That is 3 unpaired electrons. In 3D8, we'll be having 1, 2, 3, 4, 5, 6, 7, 8. We'll be having 2 unpaired electrons. In 3D3, we'll be having 1, 2, 3. That is 3 unpaired electrons. And 3D6, we'll be having 1, 2, 3, 4, 5, 6 with 4 unpaired electrons. That is why the D option will be correct. Please put this down. For example, this was a question that is based on a concept that you have magnetic moment and it is one of the very important topics, and this is a topic that you cannot forget easily. You don't have to study this topic specifically. I mean, if you are studying the DNF block elements of coordination compound, or you're studying chemical bonding even in 11th standard, then also you are going to learn about magnetic moment. This is a topic that you cannot leave off. So, moving on. Try this. Which of the following statements are correct about Zn, Cd, and Hg? Important thing about Zn, Cd, and Hg is that all of these are having D10 configuration. Okay, so please try this. These are the options. Try this going answer. Take again, same 2 minutes for this. Okay, Maria. So most of you have answered me now. So I'm explaining this. They exhibit high enthalpy of atomization as D subshell is full. Now, thing to understand here is, if the D subshell is full, that means the D subshell will be stable. And if something is stable, then all the D electrons will be attracted by the nucleus. And when all the D electrons are attracted by the nucleus, they are more closer to the nucleus. They are not available for metallic bonding. Not available for metallic bonding. That is why this statement is wrong. So the option that I can remove from here is C option cannot be correct. Now let's move on to another. But Zn and Cd do not show variable oxidation state, while Hg shows +1 and +2. Yeah, that is true. Zn Cd का नहीं होता, Hg के लिए HgCl2 भी होता है, Hg2 Cl2 भी होता है. ठीक है. This is true. The compound of Zn, Cd, Hg are paramagnetic. हो नहीं सकता because we have having D10, it will be diamagnetic. So C option cannot be there. तो ये A भी नहीं हो सकता है, B भी नहीं हो सकता है, C we have already removed. So only option left is D. Zn, Cd, and Hg are soft metals. Yeah, that is true because of the weak metallic bond. This is the important point to note down. Okay, they exhibit high enthalpy. No, they will not exhibit high enthalpy. Why? Because if you are having D5 or D10, both the cases, because these are stable, they will be nearer to the nucleus. And if they are nearer to the nucleus, they will be not available for metallic bond. Okay, that is why if you see enthalpy of atomization, it increases like this, increases, and then it takes a dip for manganese. Then again, it started increasing, and then it takes a dip for the zinc case. Okay, एक dip आता है manganese की वजह से, that is because D5 again same stable, that is why not available for metallic bonding. Right, this all of these questions are something that you can attempt on your own without even specifically studying for these things. ठीक है, अगर आप सिर्फ नोट्स पढ़ेंगे ना तब भी आपका फॉर एग्जांपल K2MnO4, you treat K2MnO4 like this. K2MnO4. First of all, calculate the oxidation state of manganese. From there only you can remove a few options. No, Shahid, that is not true. देखिए एक चीज आपको हम बता देते हैं, ध्यान रखिएगा हमेशा. For example, if you have MgCl2, ठीक है ना, ध्यान दीजिए. If you have MgCl2, we don't say magnesium dichloride. So whenever you have having any kind of ionic interaction, वहाँ पे di tri नहीं use होता है. ठीक है, di tri is not used if you are having any ionic interaction. तो B option कभी नहीं है. ठीक है. Now once you calculate the oxidation state, what is the oxidation state of MnO4? So it will be 2x, sorry, because of potassium, plus x minus 8 will be equal to 0. So x will be equal to 8 minus 2, that will be equal to 6. So plus 6. So either we will have the A option or C and D. All of these options are. Now, this is what if we had something like this, MgO, magnesium oxide, right? Magnesium oxide. But because it is in a complex form, it will be oxido. Because it is what? Negatively, no? It is an anionic ligand, and anionic ligands will be having O at the end. It's a chlorido, bromido, here also it will be what? It will be oxido. Oxido. Now we are having potassium, so it will be potassium. How many oxido? Tetra. I have tetra oxido. Now, another thing is that this complex part is itself anionic, so it will be not manganese, rather manganate and 6. Okay, so it will be A option. Potassium tetraoxydomanganate 6, not 5. 6. Now, the C option is very similar, potassium tetraoxopermanganate, but यहाँ पे permanganate नहीं. Right? It is not going to be permanganate, it's going to be only manganate. Chलिए, please copy this. If you would have read the option, then it would have been even more easier. Potassium tetraoxydomanganate, this can be there. I mean, there is no problem in this name, even if it does not matches the compound that has been given. The name does not have a problem on it itself. But if I look at the second name is having a problem. That is dipotassium. So this di cannot be there. The third name, if I see, then it is permanganate. Now, permanganate, like if you have anything per, for example, H2O2, it is peroxide. You have H2S2O8. This is peroxodisulfuric acid, right? So whenever you are having per, na, तो यहाँ पे जो central atom will always have two of its molecule. Yeah, correct. VM parameter. यहाँ पे एटलीस्ट आपके पास ना दो होगा. I mean, जिस तरह से S2 है, H2 है, उसी तरह से पर सेंट्रल मेटल एटम और एनीथिंग अदर देन द ऑक्सीजन शुड बी हैविंग two atoms of that element. तभी पर होता. Now here we are having next is potassium tetra. That is why this C option could not be. C option भी नहीं हो सकता. Potassium tetraoxydo manganese. Now if this is anionic, it will not be manganese, it will be manganese. So this option cannot be. Okay. So these names are not correct. Okay, moving on. Try this. This is also a bit logical because chromium और manganese की atomic number and electronic configuration आपको तो पता होना चाहिए. At least 30 तक तो पता होना चाहिए, है ना? In general, without even specifically trying, without even specifically learning or preparing for examination, chromium and manganese, you should know what is the electronic configuration as well as the atomic number. है ना? So from that information, you can extract and do this question. Please try this. I'm giving you guys 2 minutes for this. One answer. Approximately 30 more seconds. Okay, yeah. Sorry. चलिए, please see. In aqueous solution, Cr2 positive is reducing. Reducing का मतलब क्या हुआ? This act as a reducing agent. If it is acting as a reducing agent, then what will do? Cr2 plus oxidizes easily. इनका कहने का ये मतलब है Cr2 plus will oxidize easily. ठीक है. Next is Mn3 positive is oxidizing in nature. That means ये क्या कह रहे हैं? Mn3 positive will reduce easily. मतलब ये आप थोड़ा सा ध्यान दीजिएगा यहाँ पे, मतलब आपको कंफ्लिक्टिंग रह सकता है. Cr2 plus is reducing का मतलब it is going to reduce other. That means it oxidize, it itself get oxidized easily. Mn3 positive is oxidizing in nature. That means वो खुद क्या हो सकता है? वो खुद reduce हो जाएगा. ठीक है? It is going to reduce itself. मतलब it is going to undergo a reduction आसानी से. ठीक है ना? Will reduce easily. ये reduce मतलब क्या कैसे लिखे? आप बस भावनाओं को समझिए. ठीक है? So let us see if this is true or not. We are having Cr2 positive. Cr2 positive, if it is oxidizing, if it is getting oxidized easily, it will be Cr3 positive. Now we will look at the electronic configuration in both of these cases. Sakti V Kra. Kra is what? 24. 24, that means, like I am writing here S2D4, even though it is wrong, but it is going to work. Why? Because the original configuration is S1D5, right? But if I'm going to remove two electrons, it will be what? You remove one electron from S and you have to remove one electron from D. That will be S0D4. Even if you remove the electrons from here, it will be the same thing. There's no change here. ठीक है? अच्छा, अब देखिए यहाँ पे next what's going to happen. S4, S0D4, and here it is going to be S0D3. Now D3 configuration in aqueous solution, it is going to form a complex with water, and there will be an octahedral splitting in which you will have something like this. And you are having T2G3. Now T2G3 is what half filled, and that is why it will be stable. So this reaction is very much feasible. Now we have to look for Mn3 positive. In Mn3 positive, that Mn3 positive is oxidizing. That means Mn3 positive can undergo reduction easily. It will get converted to Mn2 positive. Mn3 positive is what? Mn is S2D5. S2D5. So 3 week Raman. 1 is 25. So Mn3 positive is going to be S0D4 and Mn2 positive is going to be S0D5. Obviously, because this is half filled, it is going to be more stable. So yeah, this statement is true. The reason that they are giving is extra stability of half-filled electronic configuration is observed that incompletely is observed than incompletely. Yeah, that is also true. And that is also the reason why this first statement is true. Both of these T2G3 half-filled and SD5 is also half. So both A and R are true, and R is the correct explanation of A. This is the correct option. Okay. So chromium 2 positive से chromium 3 positive पे याद रखिएगा. It is because of SD3. SD3 is what? T2G3 की वजह से stable होता है. Moving. Now, these are the questions which are going to be a bit daunting because they're completely factual. I'm giving you guys 2 minutes for this. Like this is taken from the text of NCERT itself. If you remember if you slightly remember the structure of chromate ion, then you can answer. First one, if you, this is from structure, this is from MOP. This is literally a text in the NCERT line. So this is in text, I would say. Then this is again from the MOP of calcium permanganate. This is something general. इसके बारे में I think you can answer this one. With increasing oxidation number of transition metal, ionic character of oxides decreases. ठीक है, तो we know that ionic character किस पे डिपेंड करता है? Ionic character versus covalent character. अगर आप लोग याद हो फजान रूल से देते हैं, फजान रूल. So according to Fajan rule, what is going to happen? The ionic character, it is always inversely proportional to the charge, right? Or the oxidation state. For example, if I talk in the case of, if I take the same group, for example, potassium and calcium, there are potassium or calcium, potassium, and then we have calcium. Potassium is positive and calcium is 2 positive. So calcium will be showing less ionic character than potassium because of the charge. Potassium 2 positive बहुत ज़्यादा highly charged है, that is why it has a greater polarizing effect in polarizing the anion. This statement is true. With increasing oxidation number of transition metal, oxidation number increases, so obviously the charge of the metal atom is also going to increase. The ionic character of the oxide is going to decrease. This is true. Now we have only what options left? We have option number A, which can be true, or option number C, which can be true. अब यहाँ पे B, D, E है, यहाँ पे so D is true. आपको क्या देखना है? A और B में बस अब देखना है. ठीक है? Now you can answer a bit. A and B में देखना है आपको. If you remember slightly bit about chromate ion is going to have a tetrahedral structure. ठीक है? Chromate ion जो होता है आपका, it is Cr, then it is having 4 oxygen atoms, and then the overall charge is 2 negative. This is the chromate ion, and this is what tetrahedral in shape. So A is false. If A is false, the C option cannot be true. So only option left is the A option. B, D, and E. The heavy magnet is also paramagnetic, is not diamagnetic. So the good thing about identify the correct statement below. In this case, if you know at least 1 or 2 type of things, then you will be able to answer these questions. And for this, you need to read NCERT. Like all of these questions are directly from NCERT, but this is not something that you will always retain in your brain while studying for the board examination, right? Board examination, generally we talk about trends and why type of question, why is there, why that, and this is completely factual. अब इसी तरह के सवाल ज्यादा है. Like we have seen some logical questions also. For example, this chromium and manganese white type of question. Then this is, I mean, general question, not very hard, even though it is factual. But then next we have, these are all logical questions, right? All of these are based on the fact because that ZNCD and HE are what D10. Then the previous one was quite easy, generic question. Now what we'll see the most of the question. For example, the next question also. The metals which are employed in the battery industries are. I mean, you cannot literally prepare for this. You can just read the NCERT once, the DNF block. I mean, this question will not be obviously repeated. इस तरह के सवाल आ सकते हैं. यानी कि that means you have to also look at what the uses of DNF block elements. जो हर chapter के end में you have to read that also. Application of DNF block. Try this. इसमें भी कुछ ऐसे जनरल नॉलेज आपके पास होगा तो फिर आप इसको कर सकते हैं. बैटरी तो आपका इसमें भी है ना, उसमें कम से कम एक बैटरी, कुछ तो याद होना चाहिए आपको। थोड़ा सा हम आपको टाइम देते हैं, थिंक फॉर लाइक 2 मिनट्स। ये मारिया। Fine. So we are getting answer. So the answer for this question is, एक आपने थोड़ा सा, अगर हम आपको जब आंसर बताएंगे तो आपको याद आएगा, निकल कैडमियम बैटरी। This is something that you must have learned in electrochemistry कि जब आप बैटरीज और सेल वगैरह पढ़ेंगे तो निकल कैडमियम आपने पढ़ा होगा। So obviously nickel and cadmium will be the options. Nickel, cadmium, and there is only one more, that is manganese. MnO2 को यूज किया जाता है in the dry battery cells. ठीक है? So only these two. So we are having B, C, and E. Yeah, correct. Option number D. These आयरन एंड क्रोमियम आपने कभी सुना भी नहीं होगा, दैट दे आर गोइंग टू यूज। निकल एंड कैडमियम के बारे में हमको थोड़ा सा उम्मीद था, निकल एंड कैडमियम आपको शायद याद है। Moving on. So you have to what you can see that at least in one of the papers they are asking what from the applications of D and F block elements. You need to read the NCERT, उसके अलावा और कुछ ये नहीं है, you read it line by line. By the way, this question is like important. If you know this, इसको करने के दो तरीके दोनों हम बता देते हैं। लाइक एक तो सही आंसर आपको पता हो, दूसरा आप अगर सही आंसर नहीं पता हो देन ऑल्सो यू कैन यूज वट एवर यू हैव नॉलेज अबाउट। What I would suggest is ना, calculate the oxidation state of chromium here and calculate the oxidation state of manganese. ठीक है, उसके बाद फिर आपको आंसर पता लग जाए। Calculate the oxidation state and you will get to know the answer. Now this question is not there in NCERT. And this is not discussed in NCERT at all. Take 1 minute for this, इससे ज्यादा टाइम नहीं, ऑक्सीडेशन स्टेट 1 मिनट में निकल जाएगा आप लोगों का। टेल मी द ऑक्सीडेशन स्टेट इन द चार्ट एटलीस्ट, कम से कम वो तो कर सकते हैं, क्रोमियम का इतना, मैंगनीज का इतना। जल्दी ऑक्सीडेशन स्टेट। यस मारिया फादल करेक्ट। ठीक है, अब देखिए यहाँ पे, so if they are in that oxidation state, how many d electrons will be there? Maria and Fadil, both the cases. For chromium and manganese, how many d electrons should be there? d में कितने इलेक्ट्रॉन्स बचेंगे क्रोमियम के लिए और मैंगनीज के? So Maria, can you give the answer now? You can eliminate many options now, है ना? Yes, that's correct. Fadil, what about you? How many d electrons will be left in those oxidation state? तो Fadil, वो नहीं आ रहा आपको? देखिए, so I hope all of you have got the chromium is having +6 oxidation state, manganese is having +7. Their electronic configuration is S. chromium के लिए S1D5 होता है, S1D5. So total there are 6 electrons. All of these electrons are what? Removed. That means यहाँ पे D0 है. In similar, in the case of manganese also, you are going to have S2D5, right? And here you have +7 oxidation state. That means here also D0. If there is D0, तो D transition कहाँ से होगा? So all of this B, C, D options cannot be true. Either the D transition can take place for K1O4, nor it can take for K2Cr27. तो दोनों का केस तो बनता ही नहीं है, ठीक है? The only option left is that is the charge transfer transition in both the case. अब what is charge transfer थोड़ा सा हम आपको बता देते हैं. Like if you have not studied in detail, तो इसमें बहुत ज्यादा फायदा नहीं होगा. Whenever you are going to have oxides ना, oxides की वजह से क्या होता है? There is a bonding. एक तो bonding आपके पास sigma bond होता है. Sigma bond that is from the ligand to metal, और एक होता है metal to towards the pi star, जो कि आपने कार्बोनिल्स के केस में भी पढ़ा होगा, right? So we have a overlapping between the p orbitals of the ligand and the d orbitals of the metal atom, and because of this, what is going to happen? Because of this, we say that we are having LMCT, ligand to metal charge transfer, and because of this there is color. यहाँ पे जो ट्रांजिशन होता है ना, this transition की वजह से there is some color. ठीक है, तो आप लोग ये याद रखिएगा, सी हाउ यू कैन चार्ज ट्रांसफर आपने पढ़ा भी नहीं था, बट वट एवर नॉलेज यू हैड दैट कैन बी यूज्ड टू आंसर द क्वेश्चन जस्ट बिकॉज इट इज एमसीक्यू. ठीक है, चलिए मूविंग ऑन. अच्छा, अब जाके आपके पास है थोड़ी चीजें जिनको आपको नोट डाउन कर लेना है. ठीक है, these are the electronic configuration of the 4F series. There are multiple questions which have been asked directly from the electronic configuration or a bit of application. ठीक है. Now, if you look at the electronic configuration, there are few things that you should note down. एक तो सबसे पहले we are having cerium, that is 4F1D1. There are few which are having D also in there. ठीक है, इसको याद रखिएगा. This is 4F1D1, and then there is one thing. The general electronic configuration for all of these lanthanides are what? It is +3. General oxidation state, general oxidation number. And there are some deviation here and there. There are some deviation here and there. For example, terbium की अगर आप बात करें, तो terbium it is 4F8 in +3. इसमें आप क्या कर सकते हैं? +4 भी oxidation state हो सकता है. Why? +4 can exist because in +4 oxidation state you will be having 4F7 because of half field. ठीक है? Make sense? Yes or no? Please tell me, guys. In the case of terbium. ओके, अब यहाँ पे देखिए कुछ चीजें बहुत इंपॉर्टेंट है. दैट मीन्स ये आपके पास जो +3 ऑक्सीडेशन स्टेट होगा टर्बियम का, इससे +4 जाना आसान है. You can go from +3 to +4. What is happening? This is oxidation is happening. That means we can say that terbium is going to be a good reducing agent. ये कह सकते हैं. Another thing is gadolinium. Gadolinium is going to have, gadolinium आपके पास 0 से ये +3 आसानी से चला जाएगा. ठीक है, it can go from 0 to +3 very easily, right? Because it is having half field. That is why we can also say gadolinium. It is also is a good reducing agent. Fine. You can please note these all of these electronic configuration down. Have a star point for gadolinium. Have a star point for terbium. Similarly for yttrium and lutetium. Okay. In the case of yttrium, +2 oxidation state is going to be more stable. Why +2 is going to be more stable? Because in +2 oxidation state you will be having 4F14. Similarly for the case of lutetium, if you are going to see, it will be a good reducing agent. Why it will be a good reducing agent? Because you +3 oxidation में half field show करता है. Fine. So please write all the electronic configuration. Write all the electronic configuration and then star mark these: cerium, gadolinium, terbium. Please raise your hand also done writing. No, Padal, you have only one chem class today. I anyone still writing? Please let me know. I think I have given enough time. Anyone still writing? Okay, fine. Write the next for that is actinides. Please note this down also. चलिए, let us see the questions now. The first question is regarding diamagnetic lanthanide ions are. And like if you know these La and cerium, lanthanum and cerium, and all of these atomic numbers, then only you will be able to do the calculations. So if you have written this down, this will be easy for you guys. The diamagnetic lanthanide ions. You have the electronic configuration, ये तो हो सकता है फिर. By the way, like please remember one thing, please यहाँ पे ध्यान दीजिएगा जरा कि जैसे आपके पास हम ले लेते हैं फॉर एग्जांपल लैंथनम, ठीक है. सो अगर लैंथनम में ना यदि इलेक्ट्रॉनिक कॉन्फ़िगरेशन इज लाइक दिस 4f0 5d1 एंड 6s2, फाइन. अपने आप यहाँ से 3 पॉजिटिव, तो ये तो हो जाएगा. सीरियम का एग्जांपल, तो सीरियम विल बी बेटर. सीरियम में क्या होता है, या 4f1 5d1 एंड 6s2, ये ना सीरियम, या सी 4f1 5d1 6s2. Now in the plus K oxidation state, whatever electron is left ना, जैसे मान लीजिए आपके पास neodymium में, in neodymium let us suppose we are having 4f4 and 6s2. In plus 3 oxidation state, what is going to happen, you are going to remove from 6s, you are going to remove from 4f, and 4f3 will be remaining. उसी तरह से देखिए, अगर गैडोलियम की अगर हम बात करें, तो इन गैडोलियम इफ आई एम टेकिंग, इन सब केसेस में उतना दिक्कत नहीं होगा आपको. Here it will be a major difficulty. For example, for example here thorium. In thorium, if I am going to take plus 3 oxidation state, तो आपके पास बचा रहेगा 61. बट दिस 61 डज नॉट रिमेन, ये किसमें चला जाता है, 5f में चला जाता है, 5f1 हो जाता है. ठीक है, तो इसको बस ध्यान रखिएगा. whatever electrons are remaining, they will go to the f subshell. Okay, Tarif, waiting for a few more answers. Take one more minute. Clear, right? In both the cases I've shown, lanthanum or cerium की केस में क्या होगा, you will be having what, one electron remaining in both the cases, right? So that is why both, I mean sorry, not one, there will be 0 electrons. For example, cerium की केस में क्या है, cerium it is 4f1 5d1 6s2. You remove the 4 electrons, you will be left with what, 0 electrons. All the inner shell electrons are filled. तो क्या होगा, डायमैग्नेटिक. लैंथनम की अगर हम बात करें, तो लैंथनम इज गोइंग टू हैव व्हाट, 4f0 5d1 and 6s2. remove 3 electrons, it will be what, 0 मतलब क्या हो गया, all the other inner shell electron are what, filled. That's right, lanthanum positive and cerium positive, these are both of these are going to be diamagnetic. अगला सवाल है, देखिए, this is also important. which of the following acts as strong reducing agent? इलेक्ट्रॉनिक, आपके पास एटॉमिक नंबर दिया हुआ है. This is going to be a bit easier answers, बहुत ज़्यादा hard नहीं होगा. Look at the oxidation state and the general oxidation state for actinides and lanthanides are what +3, है ना? उस हिसाब से आप आंसर कीजिए, then you will be easily answering. Yes, correct. Clear, guys. देखिए यहाँ पे all of these are in what higher oxidation state. EU2 positive ही ऐसा है जिसमें क्या है in lower oxidation state. So EU2 positive can easily go to EU3 positive, that is the general oxidation state. So this will be the correct option. ठीक है, EU2 positive. Also एक चीज आपको बता दें, like even if let us suppose gadolinium या फिर lutetium में +4 oxidation, it is going to have 4F7, but it is inherently difficult to go from +3 to +4, है ना? It will be always easier to go from 0 to +3, है ना? +3 से एक इलेक्ट्रॉन निकालना ना फिर भी मुश्किल होता है. ठीक है, so even if you have a comparison ना 0 to +3 and +3 to +4, तो 0 to +3 को ही चूज कीजिए. चलिए, moving on. Now this is regarding the reaction. Heating KMnO4. In this reaction, if you remember, you will know it. Otherwise, KMnO4 तो heat कीजिएगा तो you will get K2MnO4 plus manganese oxide and you will get oxygen. ठीक है, you can balance this out. And this all of these reactions are there in here. Yeah, NaCl reacts with H2SO4 and K2Cr2O7 to give the reddish fumes B, which reacts with NaOH to give yellow solution C. B and C are respectively. यहाँ पे देखिए ये वाला सवाल यहाँ से होना चाहिए. NaCl reacts with H2SO4. NaCl considered H2SO4 से react कर रहा है and K2Cr2O7 से react कर रहा है. So NaCl plus K2Cr2O7 is main thing. This is happening in H plus in acidic medium. Even if you remember now what is the yellow solution, उससे भी शायद आपको थोड़ी मदद मिल जाए. Clear. So this reaction of NaCl with K2Cr2O7 in acidic medium is going to give you CrO2Cl2, which is going to be red in color, CrO2Cl2. This yellow solution is लिंक कोई थोड़ा सा याद होगा आप लोगों को because this is in NCERT Na2CrO. ठीक है. So A option will be correct here. Na2CrO4 is discussed in NCERT. Moving on. Hi, this is again regarding the electronic configuration. What one answer? Okay, in lanthanides, formation of Ce4 positive is favored by its noble gas configuration. Ce4 positive is strong oxidant reverting to the common +3 oxidation state. ठीक है, देखिए यहाँ पे C. So C4 positive will be is it noble gas configuration? Yes, because 4F1, 5D1 and 6S2. ठीक है, ये होता है इलेक्ट्रॉन कॉन्फ़िगरेशन इसका शायद, है ना? So what you can see here is that you are having 4 electrons. इसको निकाल देंगे, then you will be having the noble gas configuration left. So this is true. And since C it is in +4 oxidation state, it can go to the common oxidation state, that is +3. What is happening with C +4? It is getting reduced. So if it is going to get reduced, it is going to be a good oxidizing agent. So this is also what true. But यहाँ पे एक चीज I think हाँ ठीक है, this is also true. So both statement 1 and 2 are what? So you try one more. ये हो जाएगा आप लोगों से because it is easy. I mean, even though आपको पैलेडियम का नहीं पता होगा, but निकल, आयरन एंड कॉपर ये सारी चीजों का पता होगा, डीएनए कॉन्फ़िगरेशन पता होगा. Identify the one which is not going to have detailed configuration. We have got one. This was easy. It was not very difficult. It's Shahid and Maria, correct? Giving you guys one more minute. और try कर लीजिए आप. Fadil and Tarif. My father